Okay, the ebonite stock is mounted in the XY vise, and we're ready to cut the tenon. Before doing that, a word about the cutter itself. This device here, the source of this, there are basically two versions of this type of cutter on the market. One of them is low cost and does only approximate work. It's perfectly fine for getting tobacco access devices back into service. That's what it's for. But you will not be able to do high-grade invisible replacement type stuff with it. That requires one of these, and there's only one source of these that I know of. A fellow in Columbus, Ohio, USA. His name is Tim West, like the direction, W-E-S-T. And his father-in-law used to be a professional machinist, and he made them for him until he retired. And now there's a guy in, of all places, Sundance, Wyoming, who makes them for Tim. And he's got a supply, keeps a supply in hand. And I've seen the new guy's, his name's Tony Maddox. I've seen his work, and it is outstanding. The machines that Tim West sells are as good or better than they've ever been. So there you go. And another point to note here is the actual measured diameter of the original stem is 0.304 to 305. It varied a little bit, but we are going to shoot for 307 with this cutter because we have a couple steps at the end that'll remove the last thousandth or so and leave it shiny and nice. So you want to, your target should be slightly larger than your desired finished result. Alrighty, now because this is a fairly significant diameter stock, I've set the machine to just take not do it all in one bite. They're not really designed for that, and it doesn't take much longer to do it twice. So anyway, here we go. Okay, that's the first pass, and now we measure and do a little math to see how much farther in to go on the next cut. And we're sitting at 696, and we're aiming for 307. So 696 minus 307 divided by 6.5. And what's that, you might ask? It's, I, through testing, have determined that each of the index marks on this is 6.5 thousandths of an inch. So you just work backwards from there and determine how far you need to go. You take the total distance, divide by 6.5, and that gives you the number of little index marks that you crank this guy. Alrighty. Okay, I turned the little guy, did the arithmetic, turned the ring, tightened it back up, and we are ready to make the second pass, which should bring it fairly close to the finished dimension, but it's not going to be close enough. You want to save the last pass to be just a shaving type of thing. And in case you're wondering, the post on this does not spin. You'd think that that would have to roll in order to not get hot when it's in a hole. And I devised a method of actually cutting a barbershop pole type of pattern on this using a belt sander and a cordless drill. And the spiral scratches on the surface of these guide pins hold beeswax, which is what this is, in a quantity sufficient to lubricate that pin. And it sounds weird, but it works. It's you can spin it in there for half an hour and it just barely gets warm. I don't know the physics involved, I just know that it works. So don't assume that any cutter that doesn't have a rolling or spinning pin is going to work badly, because that's not the case. Alrighty, we're ready for pass number 2. Here we go. Same as before, we measure what we've got. It is 435. And once again, do the math. 435 minus 307 divided by 6.5. And I know just how many index marks now to do it. I'll let you watch me this time. I need to go 19.6, so I'm actually going to move only 18 just to sneak up on it. There's 5, 10, 15, 18. And this ought to get us very close, but you really don't know until you do it. So this should be the last cut other than a final shaving of tissue thin, like just a thousandth or two. So here we go. Okay, because we got this is so large in diameter and we got inside the width of this cutting blade, we got a little chatter right at the end. It's no problem. We're going to not use that portion anyway, but that's what that was all about. On a lathe, of course, you wouldn't have anything like that happen, but every system has its strengths and its weaknesses. Okay, we are down to 0.319. So we got only one cut left to go, and we will be cooked. And we're down to within about 3 or 4 thousandths of our target. Okay, we're ready for the final cut. Made the adjustment on here. I speeded up the machine so that it's the rotational speed's now 840. A little bit faster gives you a slightly finer polish. You kind of have to keep track of which materials are most agreeable with which speeds, especially when you're working with acrylic. But anyway, in this case, I think we'll get our best cut at 840, and we've got to make the final cut's only about 5 thousandths of an inch. So you won't see much, but it's an important step. So here we go. Okay, the final step now with this particular tool, we might as well check the diameter, but I'm sure we're where we want to be. Yep, we're about 308, so as close as we're going to get. And the next step is to cut the length of the tenon exactly where we want it. And the best way to take the measurement is to modify a set of calipers so that the shape of that, the top one, it's hard, I didn't make a drawing or anything, but it's designed for one purpose and one purpose only, which is to fit like so and give you an accurate height. And then you transfer that to the one you're cutting. In this case, we've got about 1.5 millimeters to take off of that guy. So I will measure that off, get it taped up, and come back when we're ready to make that cut. Okay, the overall length of the tenon, the measurement has been transferred. It's marked with tape. At the top of the tape is as long as we want it. And the cutting blade on this spinning guy here has been moved all the way in until it's touching this post. And we've slowed it way down in cutting speed so we have better control. And we'll just trim this thing to length, and it's far better than to do it by hand like with a file or sandpaper or something, because it's going to be absolutely square, right angles to the bore, which is what you want. Alrighty, and that is all that we're going to do at this station for this stem. So I'm going to shut the camera off, set up to do the next step, and keep the show on the road here.